This is section 1.3 in your book called Electrons, Bonds, and Lewis Structures. So what we're going to talk about here are exactly what are electrons, what are bonds, and how can we talk about both of these using Lewis structures. So there's a nice little write-up in your book about electrons, and they show how two hydrogen atoms come together to share two electrons and form a bond to make the diatomic hydrogen molecule. And it turns out that if you simply pair two hydrogen atoms together in this way, by letting them share an electron or two electrons between each other, then what you get is a lot of energy just by making this bond. In fact, you get negative 436 kilojoules per mole, which is a lot of energy indeed. And how precisely this bond is formed from the two electrons is kind of shown here in this diagram. In general, energy increases as you go up the y-axis, and internuclear distance, that is the distance between the two atoms, goes down as you go left towards 0 on the x-axis. So we start with the two hydrogen atoms infinitely apart from each other, and as they come together, you start to have some interaction between the two electrons. And as the interaction, or as the two atoms get closer together, you start having forces such as attraction between the proton, the nucleus, the positively charged nucleus, and the negatively charged electron on the other atom. That force starts to get stronger, as does the force of repulsion between the two electrons, which is considerable, and the repulsion of the two protons with each other. Because the electrons are negatively charged, those two negative charges repulse each other, and the two nuclei are positively charged, and those charges repulse each other. However, the strength of the proton, or the nucleus, the positively charged nucleus, to the negatively charged electron on the other side is so strong that as you get the two atoms closer and closer together, you start to continue to gain energy, negative energy, meaning more stable, until you reach some optimum value where that attraction between the nucleus of one and the electron of the other keeps the two atoms at a distance here, 0.74 angstroms, and you have a formal bond that is formed between the two atoms. However, those two repulsion events, both the nuclei and both electrons, become much stronger as you go any closer than this optimum length. And so then the energy starts to increase again, which is bad, and the molecule becomes much less stable. So the two hydrogen atoms would much prefer to share the two electrons at a distance of 0.74 angstroms. Now, that was a very large explanation just to talk about what a bond actually is. And that doesn't even tell us how to talk about bonds and electrons in between each other. To do that, we need to use the Lewis dot structures that you learned about in general chemistry. And you can see from this small periodic table, or part of a periodic table that's in your book, we're going to be using primarily these atoms and mostly just the top row of the P block here. So if you remember, atoms always want to get to this eighth period marked 8A, and they have valence electrons that correspond to their period number. So boron has 3, carbon has 4, nitrogen 5, oxygen 6, and fluorine 7. And we can draw how many electrons they have in their valence shell simply by using the Lewis dot structure rules that hopefully we're all familiar with. So we can look at this on the tablet and see that for boron, we would draw in its 3 valence electrons like so. For carbon, we would draw in its 4 like this, going around the atom each time. For nitrogen, it has 5, so we would draw the 5 like this. For oxygen, it has 6, so we would go, around the oxygen atom, eventually ending up with 6 total. And for fluorine, we would do the same, eventually ending up with 7. Whenever we draw atoms in to make a bond, generally, like in this case, we will make a bond by aligning 2 electrons in a Lewis dot structure. Some of you may have learned to connect these with a line or perhaps draw a circle around the 2. That's not necessary. In this case, you can just leave them like this. So using Lewis dot structures, we can start to understand how atoms are arranged around each other and how bonds are formed between atoms to start to make molecules. And this has been section 1.3.